Okay, let's make sure that everything is working before we get started. I've had to be messing with OBS a lot because it keeps breaking. I want to hear that we have audio going out, which I don't think we do. Okay, there's something, I think. I think we might have audio. It's just going out for the wrong device. Never mind. I'm just going to assume everything's working fine. This is a power supply for an industrial device which shall remain nameless. And I've done a few of these in the past. They're from the late 90s, mid 90s-ish, I think. And they just wear out over time. And there's basically a standard service I do on them to bring them back to life. So it's nothing out of the ordinary at all. We have a couple of resistors we need to swap out. All of these secondary side caps are going to get swapped out. This big primary cap, I'm actually waiting for these devices. The first time I see a failure of these, I'm going to start swapping them out. But not a single one has failed yet, so I've never done it yet. Other than the capacitors, they get a few solder joint failures and things like that, and we're just going to be going through it. And now I was going to be looking for a resistor to replace this guy. It's getting a bit worn. I'm going to see if I have one in the box, otherwise we'll just have to make do with that one. That would be a 6.8 ohm one. Yeah, and I don't actually have a proper replacement for that. Don't even think I have a second-hand proper replacement for that anywhere at all, which is a bit annoying, but oh well, we'll have to make do. So these power resistors on this particular boards, they just run rather hot, and I like to swap them. They usually fail catastrophically when they do fail, so it's not usually. Stay put, stupid camera. It's not usually a problem. That camera is not staying put at all. Stay put. There we go. It's not usually a problem with this particular one, but still nice to replace it when it gets worn down. And this one's actually gotten a bit buckled from an impact as well. Let's just waffle on and get on with it. So we have a bunch of caps. I've brought them out here preemptively. So we have a 2263, a couple of 2250s, I think, or 35s, and a couple of 1050s. And we have a 150 volts, which I forgot to fetch. Should have done that as well. It's a lot easier to just fetch all the parts before you need them. There we go, a 150. So let's just get on with it. Now this separate board also tends to get a bit wonky with time. It runs a bit hot and the solder joints just fall apart. Trady Trev asks, if we change the battery, will it lose its program? I always worry about that when working on PLCs. Yeah, when you're swapping the battery on a PLC, just make sure you have it plugged in. It always says that in the programming manual for the things. Just make sure you have it plugged in. never ever mess with a PLC if it doesn't have mains power. It's gonna get very expensive. So the 150 cap I just pulled off. It's one of these blue Phillips things. They tend to kind of leak a little sometimes, so I like to clean underneath them, just to make sure we don't get any future corrosion issues. Car4 asks, what's wrong with it? Likely there's actually nothing really wrong with this one. It does have a few obviously bad solder joints, which we can pull up on the microscope for all to see. I don't think this one has actually gone so bad as to cause a failure yet. It just pulled out with another failed component, but they can see a very bad solder joint on a resistor. But it hasn't failed. Oh, yeah, it has actually failed all the way through. It's a bit difficult to make out of a microscope, but there are cracks around the legs there. So we do have bad solder joints on these. It's a common. I've developed a bit of a fix for that, an ugly fix, but a fix nonetheless. We also have bad solder joints on the switching transistor there. We can just pull that up on the big screen. Where's my microscope? There's my microscope. There's my face. Hello. So that's the solder joints for the switching transistor. You can see cracking there all the way through. Again, a bit difficult to make out on my terrible camera. And on the big power resistors, which just run extremely hot on this board, we have that's not really an obvious crack, nor is that one, but those are cracked. You just need a much better camera to actually see it. And of course we have the very big obvious cracks on this power resistor here. That's just extremely obvious. So there's actually a decent chance that this board was part of the reason that the machine failed this time around. This is part of a pretty big installation. They go bad every now and then, and they have to come in for service due to just a general wear and tear. I'm not a huge fan of the design of these boards, given the size of the machines they go into. I think it's a bit cheap to run the resistors as hot as they do. And the soldering quality is generally not good. My side cutters are disappeared. Where are my snips? Where are my snips? Fun fact, on every stream I've ever done, I've had this same pair of snips. I got these like many years ago, and I've never had to get another pair. If you can buy a Piergiacomi pair of snips, they are very, very good. So that's the first cap. Now we just go through the lot of them. Starting with the tiny one, because else we are going to forget it. That's going to be tiny little 10 microfarad. Oh yeah, I haven't set the exposure on this thing, as needs to be done, because it's always half a stop dark for some stupid reason. Yes, it's those two. So this board is its purpose in life is to be a power supply, and I desoldered the wrong thing there. It's a power supply for a bunch of power electronics, IGBT driver type things. So when these do go bad, they tend to go bad with a bit of a bang. Not that these boards ever suffer, they're far away from the action, but where the action is, there's a lot of action. It tends to be flames and fire. And a lot of expensive IGBTs getting swapped out. That's our 10 microfarad. These don't tend to leak, so I'm not going to bother cleaning. And nice new Nichicon going back in. Dundee Road says, we've all lost our side cutters. See, that's why I have exactly one set and no more. Because when you only have one set, you will find your side cutters. Because you don't have an option. Rui Costa says hello. Hello there. Okay, that's a decent chunk of it done. Let's just do the big electrolytics and then we'll move off. Fiddlesticks. My soldering iron holder has a tendency to sometimes rip the soldering iron out when I pick the desoldering gun out of its holder, so it went flying. I have several holes in the plastic floor where my soldering iron has just gone flying and landed. And you can't like catch it because you'll just get burnt. It's important to wiggle caps if they don't come out instantly, because if you just rip and tear, this is a multi-layer board, as you can see there are traces on the top. You're just going to rip the traces out, and then you're going to be trying to patch traces underneath a big electrolytic cap, and that's just annoying and unnecessary. What brand even is this? Recon, never heard of. That's like the quality of these boards, given their importance and their ability to cause things to go ballistic. It's always been a bit disappointing. But now we get a proper Nichicon. Let's use the Fatso solder, the Big Chungus solder. Big Chungus solder for Big Chungus cap. I think I might have to push that down a little bit more. Yeah. Well, these is rather tall electrolytic caps. It's really important that you actually get them pushing down against the board properly. Because if there's a bit of wiggle there, they are going to ruin their solder joints rather instantly if there's any mechanical vibration at all. So this is going to be the 2200 35 volts. Well, let's not get the soldering iron flying this time around. Thankfully this is a 90s board, so these are leaded solder joints. You barely even need to add solder to them to make them melt all nice. And if you're getting into industrial maintenance, as I've said 100 times in the past, this is going to be a large part of your life. Because you're going to figure out the problem with like some series of industrial machiney things, and then someone's going to come along and be like, oh yeah, you fixed this thing, right? Here's 100 of them. And if you're smart, you'll hire someone to do the monkey work for you. And if you're stingy like me, you'll just do it yourself. It is satisfying to be able to point to any big industrial machine and just be like, oh yeah, I had my hand in getting that thing working again. A while ago I ordered this roll of fatso solder, and it's actually amazing for these like big through-hole components. You get like more flux deeper into the joint, which just seems to make for slightly higher quality solder joints with less effort required. Carver says, I think my snips are on the floor. They shouldn't be on the floor. The floor is generally not a good place to store your tools. So these are two 1050s. Very oversized voltages on this supply. I think there's like 24 volts across these or something. Nowhere near 50 volts, which is good. The higher the voltage your cap, the longer it'll last. And that's why the capacitors on these boards are generally not what fail. I just replace them because they do get kind of out of spec after 20 plus years of operation. Almost 30. No, it can't be that old. Well, late 90s. I'm early 90s and I'm almost 30. It's terrible. No, that's not clean. There were 1050s going there. Panasonic FM for those. Panasonic FM series are mostly depreciated because the FR series are pretty much the same spec these days, but longer lifetime. But sometimes the FMs are a bit cheaper, so I go for them where I don't need super high ripple cap, like the super high spec of the FR series. Or where I can get away with a slightly larger capacitor. And for these boards which have like relatively large old capacitors, it's important to actually order capacitors which are the right size, because fitting capacitors with like the wrong pin spacing is very annoying in the long run. If you're doing 100 of them, it's just going to get on your nerves, and you're going to wish you ordered capacitors with the right pin spacing. That's why I need to master the parametric search over all the parts distributors. I didn't quite get that solder joint proper. Ah, shit. I forgot to set the title of this stream. This is not a PLC-based PC, this is a power supply. Crap. The YouTube UI for this is not very intuitive. My face is red. Working on an industrial power supply. This is not a PLC. No wonder people are confused. My bad. This is not a PLC. This is not a PLC at all. I've made this mistake many times before, because when you're streaming to YouTube, you're using two different pieces of software. Essentially, you're using the streaming tool of your choosing, like OBS Studio, where you set 99% of the settings, but that does not integrate into YouTube. So you can't actually set your stream name or title or description through your streaming software. You have to go to youtube.com/live streaming or something of that order to actually set the title of your stream. And I just keep forgetting to do that. So we've swapped out all the capacitors we want to swap out. Again, the primary side cap. The first time I see one of these guys fail, I will be swapping all of them when they come in. But I've never seen one of them fail, so we're just not. So now we can move on to fixing the solder joint failures, which these boards are kind of notorious for. And that includes replacing a couple of these guys. I like to use bigger caps. I'm out of stock of them. Bigger resistors. I'm out of stock of them right now. And we're going to be doing a slight modification to a snubber circuit to reduce the power dissipation in those resistors. And that's going to be that resistor there and that resistor there. The guys which we saw had the giant, horrific solder joint failures on them. Like, I mean, I have to bring this on the big screen. It's just kind of terrible. It's amazing how this thing has even survived this long. So that's the component mounted to a board. You can see how I can wiggle it around. Oh, I can probably just rip this out if I want to. Not quite. We're going to be damaging the VO if we try. But that's just that's a thermal cycle induced failure, or a just continuous overheating failure. More likely in this case a continuous overheating failure, just because these are industrial boards which are on 24/7. Trady Trev says something about updating APIs and stuff for OBS. Yeah, I think the latest version of OBS actually can talk to YouTube properly, but the latest version of OBS just crashes for me. It can't handle running more than one Blackmagic capture device. So I'm stuck using one camera if I use that, and I just want to use two cameras. Because I have two cameras and I want to use them, damn it. So I'm stuck using like an ancient version of OBS, which does not have any integration at all. Which is a real shame. Like, it's just such an obvious problem. I was assuming they'd fix it in like one version or so, but the crashes with several Blackmagic devices issue has persisted for like a year now. So that's one of the resistors gone, and the other one's over here. Now that's the sound the desoldering pump makes when it does not like to suck. That's better. That's the proper suck. I want to actually tin the top of these and re-suck them, because since the solder joints have actually broken rather harshly on top, the solder has had a lot of time to oxidize over time. This camera is annoying to aim. There we go. And if I just solder new resistors in here, they're not going to solder properly on the top side because there's a bunch of oxide in the way, which basically just fell off when we desoldered them. So we need to properly retin these and suck them. Else we have no chance of making a proper joint. There we go. Nice and clean. So now I can get to the... Actually, let's just So this is a modification that I've come up with for these boards. These blue caps here, they're part of a snubber. They and these resistors, they make up a snubber network for the big transformer to handle just back EMF, which can damage the switching transistor. But the way this snubber is designed, it just puts way too much power into these resistors, causing these giant solder joint failures. So I spent a lot of time experimenting with different value capacitors and resistors and stuff a while ago, and just putting slightly smaller value capacitors in there just drastically reduces the temperature of the resistors, which makes it so that they are not going to break the solder joints anymore. It is a trade-off that it might cause slightly more wear on the switching transistors, but I've had a few of the modified units in production for a while now, and they have not failed, so I'm pretty confident making this modification by now. That's one capacitor out, and this is going to be the other one. You can tell when someone's been working on the same boards a lot, well, they can just be like, oh yeah, these points go to that component without looking on the other side of the board. And they're going to pop out just fine now. Pop. Pop. Away they go. And the smaller counterparts come back in. I should probably swap out the switching transistor as well while I'm doing this, because these K1359s, they tend to go bad when the snubbers go bad. There's a more modern replacement I've sourced, which I've never seen one of those fail. The K1359 is just an ancient transistor. It's like an 80s type device. I'm not entirely sure why the manufacturer went with such an old transistor for a relatively modern design, but I guess it's tried and true. So that's our snubber modifications installed. Capacitance reduced, meaning we have more back EMF on the transistor to deal with, but we won't be eating our solder joints anymore. Gamer Paddy says he's got a desoldering gun, but they clog up easily because the inner tube is too long, so the solder sticks before it comes out. Yeah, you need to run these desoldering guns very hot. Mine is set to 420 C right now, like way hotter than you'd run a normal soldering iron. So let's see, this guy has the traces on the top side, so we're going to be soldering it from the top side, because that's what we care about. When you're using the desoldering gun, you also want to really properly heat the joint, and you want to keep sucking for quite a while. Like, you can't just do a quick boop and expect it to be done. You need to do the full 1 second suck. If you don't do the full 1 second suck, you're going to be cleaning the tube all the time. Because, you know, it's never nice when you don't get a proper suck. It's like an inadequate suck is just not good for anybody involved. There we go. That's how a new camouflage resistor is installed. Oh, Gamerpad says they ran the desoldering pump at 350C. That's not gonna get you anywhere. Yeah, run it 400 and up. If I'm dealing with some like somewhat heavy board, I'll put mine to like 450, 480. So that's how a snub is modified and repaired. I'm going to find myself a replacement transistor for that, which conveniently should be in a box right by my feet. Yes. No. That's the wrong one. This is the right one, I think. Yes, this would be the one. The STW5NK100Z is a good replacement for the K1359 in switching applications. Trady Trev says he's wondering what the original EEs thought when they were designing this thing, if it has to be modified now. And he thinks they had a budget. It's not a budget thing. I'm putting smaller components in here. Like, this is a smaller capacitor than used to be. These resistors are the same. I think they were probably... they probably had a budget that they couldn't fit bigger resistors because you can't really get reasonably bigger ones in that form factor. But they should have... Yeah, I don't know. I'm mostly just kind of disappointed. Like, the design works, but it's a design which is going to fail. Like, you know that you're designing a product with a limited lifetime, and when it fails, it will cause damage. So, yeah, I don't like that they designed the snub the way they did. I'm just resoldering another resistor which has some kind of bad solder joints. When you get solder joints which are bad enough that they have big cracks in them, you really want to suck off the old solder and put completely fresh stuff there, because the cracks will be full of oxide and you might not be able to solder in there. Right, so let's just swap out our K1359 with our SDW, whatever it is. Gamerpad is talking about soldering onto 18650s. I would not solder onto 18650s ever. Oof, these solder joints for the switching transistors are crusty with a K. Need some fresh solder to clear them out. Right. We're doing the magazine emptying. This is just going to be completely full of garbage right now. I can feel it's weighty. Hot, 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 hot. Very, very, very hot. Yeah, when your magazine has solder sticking out of the end, it's time to clean it out. But it's hot, hot, hot. these magazines are a large part of why I always wear gloves working on this stuff, because that's like 60% lead you're handling. It's not good to be rubbing your fingers in lead. That's the sort of thing that's going to make you stupid in 50 years. I'll wipe my hands off with a moist towel, just to make sure there's not any dust, lead dust that I'm breathing in. Lead, not good for humans, mammals, any organic being. Someone with a sounding fetish is just getting off right now. There we go, back in business. We were desoldering the switching transistor. Given the amount of soldering failures in this thing, we might actually have something properly broken as well. It's not impossible. It's almost loose. The funny thing about desoldering really broken solder joints is that sometimes they are so broken that you can't actually make proper thermal contact to the solder anymore, and will just be difficult to get undone. So broken that they're not even falling apart. Alcohol refill. Oh yeah. There we go. I want to get a better alcohol syringe than that, but I actually have no idea where to buy syringes like that, and ordering syringes off of eBay or something just seems like a bad idea. So we need to do the bendy bend on these legs. Something like that. There's no thermal paste on these from a factory, so I sometimes put some on there, but I think I have like my thermal paste out in the van right now, so well, let's just not bother. There's not a lot of power dissipated in these transistors anyway. Yeah, we have a case of solder joints so broken that they can't be desoldered properly here, because they did not clean the holes properly. They just sort of made the components slip out. So we're going to be filling the holes, cleaning them out with a proper suck. that should work out in our favor. It's not. There we go. That's better. Why are we constantly out of focus on the camera? And where did I put the screw? There's the screw. Dave says, try a medical supply store or pharmacy for syringes. I've considered going to those places, but I'm afraid that they're just going to have like tiny, like hypodermic syringes, like the sort of thing that addicts want. The thermal paste syringes I use are relatively large. Like you wouldn't be, you know, shooting up with this. You're going to be having a hell of a trip if you try. Or more like just instantly die. There we go. Transistor mounted. Let's not forget to solder it in place. Tracks on the bottom. We solder from the bottom. That's completely fine. These chips sometimes fail, but when they do, there's usually a bunch of things which have gone on fire around them, and I'm not seeing anything on fire here. So I think this chip is probably okay, which is good because they have not been made for a very long time, and I have a very limited supply of them. I also want to reflow these resistors right next to the switching transistor because I know they tend to fall off the board. I would like to do all the resoldering work underneath a microscope so you guys can see something, but I'm not going to have a patience to do that. And why the hell is this thing constantly out of focus? Just stop being out of focus. Focus. It is not focusing. Oh, it's trying its damnedest. It's trying. It's just trying. File not found says, never seen a chip fail, at least not on their own. Well, stay in the business for a while, and you will. The particular chip on this board, they tend not to fail on their own. They fail as a part of a cascade failure. When all the other stuff we've been fixing fails, they just tend to go as collateral. I need to use the Chunga solder for this. These big joints, they just eat solder like no tomorrow. Problem with using Chunga solder is that sometimes you get just a tad too much on your tip, and then you end up with solder joints which just don't have enough flux in them. And that's just not good quality work. So these slightly smaller ones, I'm actually using the smaller solder, even though they are still relatively large joints. Now we're going to check through that under the microscope in a moment, but I want to deal with the big stuff. This is actually a soldered on nut to the board, which has run hot and is actually falling off. So let's just resolder the nut holding the transistor in place. There we go. And this row tends also to just kind of fall off. It's in unusually good condition on this board, but it still tends to fall off, so we're going to be preemptively resoldering it. We also need to resolder the entire little slave board hanging off this thing, because they also get bad solder joints because they're full of power resistors which run hot. Anytime you have a big or a heavy or a hot component, you should resolder it. And this is the thing I accidentally resoldered and I forgot to solder back. Oops. Doing it like a machine. These are all just two solder joints for the same little pluggy bit. I'm resoldering them two and two because they're all just in parallel. And my tip is just about wide enough to heat both at once. There we go. That's the little tiny slave board completely resoldered. Oh, Dresden donated 10 US dollars. Thank you very much. The legend is back. I suppose the key part of being a legend is that you don't exist. So you do you do have a point there. Cartor says, I got a weird fault on 12 volts power supply. When I start drawing more than 10 amps, it goes to 15 volts. And it's an old school power supply. I think it's the chip that has failed on it. Sometimes that's actually capacitors causing that. Because when you get the higher duty cycle, it'll just fail to regulate when there's like more ripple across the bad capacitor. I've seen that many times in various power supplies. If you have known good caps in it, then I have no clue, but that's actually worth checking out. Bad caps can cause overvoltage. There was a bunch of notorious, I think it was high pro power supplies that came in various OE computers like around 2006 or so, where the 5 volt standby capacitor would go bad, and when it did, the 5 volt standby would just turn into the 6 volt standby and the 7 volt standby, and finally the destroy your computer standby. File not found says, tried building a power supply based on the top 224 PN chip. Do not use the top 224. They just break. Like, don't. The top 224 is used in a bunch of, I think it is, what's Victron inverters, the blue metal boxes, like fancy, expensive inverters. And the top 224, they just cannot handle any peaks, any like transients. They just break when you do that. So people plug their expensive $2,000 charger inverter into the grid like 100 times, and then the top 224 just goes poof, and then they have no $2,000 inverter anymore. So don't use the top 224. That's my advice. So I'm just checking the solder joints on this. Restin says, I like watching your content, like a Finnish big Clive minus the bear part. Yeah, if he's a bear, I'm a fox. That's actually a pretty good analogy if I do say so myself. Hey, Finnish fox, that even, like, works with my channel name. Oh, this looks interesting. Yeah, I don't like the looks of that. Sadly, my crappy microscope camera is not going to do justice, but it's this resistor here. It just looks like slightly dodgy. Let's see. I did set up hotkeys for this, but they're not working anymore. Microscope, there we go. Big microscope. A bunch of these guys in this general area look sad, but this, oh wow, yeah, this one in particular. That's an actually failed solder joint. You can see a crack right there. If we grab a needle, that is a crack. Probably overheating induced rather than thermal cycle induced. That's no good. Good thing we spotted that. I like how my camera allows you to see my face only when I'm looking down into the microscope. Stupid OBS Studio, and it's broken everything. Like, the biggest reason I haven't been streaming lately is because OBS Studio just broke and I haven't been bothered trying to fix it. But it finally seems to be working now when I rolled back to a version from like 2019. Dresden says, I watched some of your old videos earlier. Did that Michael guy ever make a reappearance? Oh god, Michael. I have some like vague memory of... Is it like the only guy who ever got banned from chat or something like that? But, I have a weird memory of some Michael, but I'm involved in so much online drama that I can't put my finger on what exactly it would have been. We need to use a smaller tip, because the big chungus tip is not suitable for solder joints of this size. I don't think Michael ever returned though. I am currently melting my oscilloscope with my tip. There we go. And is the camera completely out of focus again? No, it's just a VGA camera. If anyone knows of a good microscope camera that has USB or HDMI out and isn't like $1 million, I would be very interested. Because this Amoscope one is just terrible. In large part because the field of view is like 1/4 of the field of view I actually have. And of course it's always out of focus. Because it's like maintenance of the microscope is just bad. Oh yeah, didn't that guy get like... Didn't he get like attention from Rossmann as well? Like, wasn't that his big deal? Like, he went to Rossmann, Lewis was like, ah, yeah, okay, I don't want to deal with you anymore, silently. And then he came to me instead. Wasn't it something like that? That's a blast from the past. For sure. All of these solder joints are bad and they are not taking solder very well. SK asks, did you check out Rossmann's store? I don't like buying stuff from America, it's usually very expensive. But I might have no choice. I haven't like been doing any active research on a new microscope camera. It's just not high priority. Oh well, here's another really obviously bad joint. Which is out of frame and out of focus. Is that the one? Yeah, that's the one. Obvious cracks there. Obvious cracks. Dresden says he thinks this camera is fine. This camera is not fine. Like, the only reason you see what I'm doing at all is because I'm being pedantic and moving it around a lot. Like, it's extremely uncomfortable for me to use because it's it has such a tiny field of view that you don't see what I'm doing most of the time. Like, you'll be seeing this just a static image and I'll be working outside your field of view. That's its biggest problem. And the fact that it's 640 by 480 pixels. Which in 2021 is, you know... Yeah. And it also has like a magic mount, which seems to slide out of focus no matter how hard you tighten it down. It sort of feels like the Lada of cameras. I'm extremely lazy, so when it comes to like streaming and stuff, everything needs to just work. I'm just not going to bother doing it. Because this, like, effort. I wish I could just, like, press one button and go live. That would make my life so much better. But needing to set up microphones, set up OBS, make sure the audio devices haven't changed yet again, which they do for no reason at all. Make sure that the cameras work, make sure that OBS hasn't deleted one of your input devices again for no reason at all, etc. Making the USB connection to the microscope camera not be a piece of shit. It's just like a bunch of small annoyances that I don't like dealing with, and I'm too cheap to buy proper stuff. And when I did buy proper stuff like my HDMI capture cards, they still don't bloody well work. Like this... Both my cameras are being captured, like the video cameras are captured through like €200 capture cards, which still just works sometimes when they feel like it. And that's just... I don't jive with that. When I pay €200 for a piece of FR4 board with a few chips on it, I want it to work every time. Like, the profit margins for Blackmagic are insane on those small, cheap cards. His wine, yeah, that's my fan. I have a fan like mounted right there on a microscope, because if you don't have like some kind of extractor, it's impossible to solder under a microscope. You just cough, and you can feel the like bad stuff going into your lungs. These solder joints just, they get so ugly. They are okay, but they are very ugly. There's something about the parts on these boards, they tend to just not want to take solder on any part that hasn't been soldered previously. They don't seem oxidized, I'm not really sure why. So we get these like ugly blobby solder jobs. How's a transformer look? Oh, we actually, oh, that's surprising. We have failing solder joints on the transformer. That's actually not been a thing on these boards that I've noticed in the past. But you can see clear signs of cracking on this one. It's rather minute, but it's perfectly visible. Like that there is a beginning crack. I can shove my blade slightly into it, and that there is also a beginning crack. You can see it going along there, and another one there. This camera does not have the pixels to really resolve that, so you're gonna have to take my word for it. Yeah, these are all kind of bad. I wouldn't say that one is worse than the other, but one might be a bit more visible than the other. I'm not sure if we can manage to cheat and just reflow them like this, or if we're gonna have to suck them. Yeah, this is good enough. They turn out ugly like all solder joints on these boards do, but that's actually... it's going to be making a good connection. I don't question their reliability. I have always reflowed these transformers just because, but that's just kind of been on the mantra that if it's heavy or it's hot, you need to resolder it. I haven't actually seen any proper failures in the past with these boards. But now we have. So now we actually have a reason to resolder this transformer. And now we're working out of frame because this camera is terrible. They look a lot better in the upper end of the board, weirdly enough. But we're still resoldering them. I should put the big tip on for this, but I can't be bothered. I just turned the heat up on this one instead. So I'm taking a long time on each joint because the flux seems to kind of work through the oxide quite well, given a couple of seconds. Trader Trev says, surely this board was wave flowed originally? Yes. Yes it was. Standard, absolutely standard production. Nothing special about it at all. Not reflow oven. It's just been in service for a long time, and these solder joints, like this manufacturer, they don't have the best solder joints. They never have, they never will. That is my review. SK says, heavy and hot sounds a bit niche. I mean, it's... read into it what you will, it's very effective. It's a mantra that allows me to keep very good quality on my work. Of course, the more pornographic you make a mantra like that sound, the easier it's going to be to remember. These joints actually look pretty good. I'm just reflowing them because it's... there's been many bad small joints here, might as well. Yep, more bad joints in this corner. We're right next to the hot switching transistor now. So no wonder that kind of bad. They've just seen too much heat. You're only hot for so long in your life until it backfires on you. And you get all old and cracked and ugly. Wrinkly. Okay, we're getting somewhere. I think we're more or less done with the microscope by now. So we can finally turn the Apple fan, which is my smoke extractor, off. And do a few more big joints, and then we're more or less ready to plug this thing in and see if it's going to give us any smoke. I still want to do these big regulators here because they're also heavy and hot. So a few linear regs. This board has quite a few outputs. Are there only two over? Yes, there are only two. But we have a few more heatsink devices in a row here. That's also another thing, another mantra. If it has a heatsink, resolder it. Okay. I start to get pretty happy with this thing now. I want to check a couple of diodes, which I know often go bad kind of randomly. It's gonna be these guys, which are avalanche diodes used in a rectifier, which is a bit weird. As long as they're not shorted, we're happy. These always fail short, never seen them do anything else. The rectifier there, I'm sure, is fine. There should be. We have this guy here, which is just a suppressor. That's fine. Oh yeah, these overvoltage suppressors these are TVSSs. TVSSs, that sounds weird. They sometimes go bad on these boards as well, but they haven't here. Yeah, there's one more over there. And this is the rectifier for that rail. All looking fine. Yeah, I'm pretty happy with that. Pretty happy with that. I think, my friends, we dare try and do a smoke test. On this, I just need to find the correct power cord for it. And there are a few different kinds for these boards. Let's see. It depends on the pin out on this mains input connector here. We have ground there, and the other two are going to be live and neutral. So 1 and 2, live and neutral, third is ground. Is it this one? Are we in luck? Yes, it is. Good. We are armed. I want to bring out my phone with a thermal imaging thing so we can see what, if anything, goes on fire. So we are somewhat warm because we've been working on the board, but that's fine. Yeah, I'm just going to turn it on and watch the power meter. That's using 1615 watts, which is way too much. What's going on fire? What's going on fire? My TVSSs are going a bit on fire. Our snubbers are going a bit on fire. That's normal. Our transistors going a bit on fire. Could be that I used caps which are a bit too small. They could be for a different series of board. So I'm actually going to bring out, I have one of these which is most probably okay. And we're going to see if that also uses 1516 watts. This is a board which was repaired not too long ago. You can see I've put much bigger resistors here. And this has the proper, let's see, yeah, well, I have put slightly smaller caps on this one. So we might actually have to revert to the original snubber capacitors and just deal with it. That's fine. It's going to run for long enough. Put that somewhere where it doesn't spark. Let's see what this thing does. I'm just kind of blindly assuming that this thing is okay. It should be okay, but we're going to find out. Well, it's also using 14 watts just sitting around, so we can pretty much assume that that's how it's supposed to be. These are not good at running idle. You can see these are the TVSSs running hot there. And that's because without a load on, they are producing overvoltage on the rails. And they always do that. So it's kind of, it's fine and it's not fine at the same time. You can't like just idle these things. Yeah, we have a bunch of stuff just running. Rather hot. But 14, 15 watts of idle power consumption is clearly normal. So I'm not too concerned with the freshly repaired unit having that much power consumption. Let's just set this, we'll call it a known good one, aside, and measure the outputs on this guy. We probably want to put a little fan on it just to make it a bit more sufferable. The poor thing is going to go on fire otherwise. Laptop fans with USB connectors, the best thing in the world. You just get tiny instant cooling. I mostly want to cool this area here. These TVSSs do run hotter than they should, but that's not the critical part. We obviously do not have a failed IC here, by the way, which is good. Now we need a wider angle, I think. Like so. Now you can almost see the meter. I don't remember exactly what the supply voltages coming out of this thing are supposed to be, but we'll figure it out as we go along. So, power on. 15 watts. Jeez. So these are the outputs here. And we don't need to be millivolts. We need to be in volts. 20 volts. 15 volts. 17 volts. Well, that's probably supposed to be 24 volts. Again, these things do overvolt when they don't have a load. And 28 volts. Let's just compare that to the other one. We also have a kind of square wave generator on this part here, which it does get supply. I think we can see that with just volts AC. I usually check it with a scope. Yeah, 35 kilohertz, 32 volts. I'm not 100% of a pin out on this thing. I think it's 4 channels. Yeah, that looks okay. Need to check that it's also coming through the little tiny board. And it seems to. So we have our AC output, we have something on our DC outputs. It is going on fire, which is completely normal for this model. 70 degrees. The switching transistor is not actually going on fire, that's only 30C. Our poor snubber resistors, 91 degrees. That's after modifications. Running it like this in its original state, they're usually about 150C. And our clamping diodes, they're getting over 100C, so we should turn this thing off. Terrible thermals because we don't have a load on it. That's like these industrial power supplies, they're not built to run on idle. It's of course good practice to make them able to survive running on idle, but generally it's not a requirement. So let's just hook up the so-called reference board and see that our DC outputs are roughly in the same ballpark. Then I'm going to be happy. We are not hot. Power is off. Power is on. Now we have 19 volts, 15 volts. That was about the same. About the same. About the same. You know, it's in the same ballpark. It's in the same ballpark. Of course, this one with the modifications installed, it does not run anywhere near as hot. The big resistors are like 40 degrees, though our snubber, our TVSSs are still going to be on fire, so they're like 50 plus degrees already, 70. But again, normal. Now this one has had, you can see those diodes there have been replaced. This one had failure on there in the past, which is very common on this model as well. But this is still our known good reference. working fine. There we go. I think we're pretty much done for tonight. That's what I do to these boards. A repair slash restoration from start to finish. So we've fixed solder joints on pretty much the entire board. We replaced a couple of resistors. We replaced the switching transistor to a more modern version. We've modified the snubber to make it go a bit less on fire. We have observed that without load, it does go on fire. Industrial stuff, generally fine. You never run it without a load. We know our AC output works. We know our DC output works. We have nice fresh capacitors which are not on fire, meaning I put them in the right way. And with that, I think we're pretty much done. I'm going to have to thank you for watching, and especially thank Dresden for donating $10 to the chat. That was very unexpected, and of course it's always nice to see that sort of thing. Even if it's just $10, my greedy butt likes money. So yeah, signing off. Cheerio.